Okay, observational studies versus experiments. The greatest difference is that treatments are assigned in an experiment, and as a result, experiments can show causation. By the way, saying treatments are assigned, as you probably remember, the most important distinction there. Treatments are assigned and they are randomly assigned. While observational studies do not have random assignment treatments and cannot show causation. So once again, observational studies are observing people do what they normally do during their typical life, and treatments are not randomly assigned. In an experiment, treatments are randomly assigned and can show causation. So observational studies, due to cost, time, convenience, and ethical concerns, most statistical studies are observational. Okay. Surveys are a type of observational study, as is a review of historical records. And that's really important because even medical records that are historical would count as observational studies. And we're basically assuming that we're watching people do what they already do. In an observational study, subjects are randomly selected. However, the treatments are not randomly assigned. Why aren't they randomly assigned? Because we're observing them do what they already do. So they've actually self-selected their treatment. All right. So they've self-selected their treatment in an observational study. All right. They're randomly selected for the study, but they self-selected their treatment because we're observing them do what they already do. Oh, I already drink Coca-Cola. That's my preference. That's what I've self-selected to do. May have randomly selected me for the study, but this is a treatment that I've chosen for myself. So statistical tests. Well, these are the tests that we were doing this third quarter. Techniques of inference to include hypothesis tests and confidence intervals can be carried out for observational studies. They also can be carried out for experiments. If we run a statistical test for an observational study, they can have a p-value that is smaller than alpha, and the null hypothesis is rejected. So they can be statistically significant. So observational studies can be statistically significant. However, they cannot prove causation. Experiments can be statistically significant and they can prove causation. All right. So once again, while observational studies can be statistically significant and show a relationship, observationals cannot prove causation. All right, so that's our observational studies. Once again, they were randomly selected for the study, but you self-selected the treatment. The individual chose their treatment because they're already doing it. You can perform statistical tests, hypothesis tests, and confidence intervals. They can be statistically significant. However, they cannot show causation, right? Observational studies cannot prove causation. An experiment, they're randomly assigned. We often use volunteers for the study because you have to, like if you had to have a cancer study, well, people need to volunteer for the study. However, the treatments are randomly assigned. So you volunteer for the study, but you don't get to choose your treatment, or we often volunteer for the study. Once again, like observational studies, they can be statistically significant, but they can prove causation, whereas observational studies cannot. The term generalizability, the finding of an experiment can be generalized to the population. All right, so the experiment is on a sample, and that sample can be generalized to the population. We want to know what population it can be generalized to, and it can be generalized to the population that looks like the sample. All right, so a large simple random sample of people aged 19 to 30 living in the state of Colorado was surveyed to determine which of the two MP3 players just developed by a new company was preferred. To which of the following populations can the result be safely generalized? All right, so we're going to say we're taking the sample and go, all right, it can be generalized to what population? Well, what do we know about the characteristics of the sample? First off, they're aged 19 to 30, and they live in the state of Colorado. Okay, so only people aged 19 to 30 living in the state of Colorado who were in the survey. This first part was very, very good, but this part means we were dealing with the sample. We don't generalize to the sample, we generalize to the population. So because that was talking about the sample, that's wrong. We generalize to the population. Only 8 people aged 19 to 30 living in the state of Colorado. This looks pretty good. This looks like this is going to be my answer. All people living in the state of Colorado. No, this is false because our sample only had the 19 to 30 crowd, so that's not true. Only people aged 19 to 30 living in the United States, and the problem with that is we only use Colorado, so that's false. Obviously, if this is wrong, then this is also wrong, so our best answer is B. Consider the following studies being run by 3 different nursing home establishments. One nursing home has pets brought in for an hour every day to see if the patient morale is improved. Okay. One nursing home hourly visits every day by kindergarten children to see if patient morale is improved. One nursing home administers antidepressants to all patients to see if patient morale is improved. So here we bring in pets, here we bring in children, and here we administer medication. None of the studies uses randomization. That appears to be true because it doesn't ever mention it. None of the study uses a control group. What's a control group? A comparison group, a group not receiving the treatment. All right, well, that appears to be true because that's not mentioned here. We just have one nursing home here. None of the studies uses blinding. That's obviously true because everyone is getting the treatment. Important information can be obtained. That's true. My voice cracked. But none will be able to establish a causal relationship. Yes, treatments were not randomly assigned. So this is not an experiment. So in this case, every single one of these things is true. It's all of the above. So while we might see that morale improved in all 3 cases, we can't say it's a causal relationship because this was not an experiment. Treatments were not randomly assigned. Number 17, a study of existing records of 27,000 automobile accidents involving children in Michigan found out that about 10% of children who were wearing seatbelts were injured, and that about 15% of children who were not wearing seatbelts were injured. So we have about 10% who were wearing a seatbelt were injured, and about 15% of children who were not wearing a seatbelt were injured. Which of the following statements should not be included? All right, whenever they give you a not, you should be doing a true, false, false. All right. Driver behavior may be a potential confounding factor. Yes, the way a driver drives could impact the study, so that's true. The child's location in the car may be a potential confounding factor. Yes, it's generally safer in the back seat, so that's true. That could be a confounding factor. This study was not an experiment, and cause and inferences are not warranted. Well, what did they say? Were they randomly assigned? Well, we really don't know, but can I randomly assign someone to wear a seatbelt versus someone not to wear a seatbelt? That would be unethical. So we can pretty well assume this is not an experiment. So cause and effect inferences are not warranted because it wasn't an experiment. The study clearly demonstrates that seatbelts save children from injury. That's a causative statement. That would be we could only make that statement if this were an experiment. So this appears to be false. We could only make that statement if this were an experiment. And then finally, concluding that seatbelts save children from injury is risky, at least until the study is independently replicated. Yep, that's also true. So our best answer is D. Number 18. In one study on the effect of niacin on cholesterol, 100 subjects who acknowledged being longtime niacin takers had their cholesterol levels compared with those of 100 people who had never taken niacin. In the second study, 50 subjects were randomly chosen to receive niacin, and 50 were chosen to receive a placebo. All right, so we have in one study on the effect of niacin on cholesterol, 100 subjects who acknowledged being longtime niacin takers had theirs compared with those who had never taken. There's no assignment here. All right, yes, we have a comparison group, which is great, but we have no random assignment of treatments. So this is an observational study. The first one is an observational study because no random assignment. In the second study, 50 subjects were randomly chosen and 50 were chosen to receive. All right, so this second one is an experiment. So the first study was an observational study, while the second was a controlled experiment. This is true. All right. Number 19. A study is made to determine whether studying Latin helps students achieve higher scores on the verbal section of the SAT. In comparing records of 200 students, half of whom have taken at least 1 year of Latin, it is noticed that average SAT verbal scores is higher for those 100 students who have taken Latin than those who have not. So if you take Latin, according to this, there's a relationship that says that you have a higher SAT scores. Based on the study, guidance counselors began to recommend Latin for students who want to do well on the SAT exam, which answer is incorrect. So once again, we're looking for false. While this study indicates a relationship, it does not prove causation. Yes, they self-selected to take Latin. They were not randomly assigned. So this study indicates a relationship. It does not prove causation. So this is a true statement. There could well be a confounding variable responsible for the seeming relationship. Yes, better students tend to take Latin and better students tend to have higher SAT scores. So it could be an intelligence as a confounding variable. Self-selection here makes drawing the counselor's conclusion difficult. Yes, the students self-selected to take Latin, and there may have an underlying characteristics that helps them do well in the SAT. A more meaningful study would be to compare a simple random sample from each of the two groups of 100 students. And taking a simple random sample from these two groups doesn't make sense because they've already self-selected. All right. They've already self-selected, so this is false. This is an observational study and not an experiment. This is true. Okay, so looking back to this last part on D, it says a more meaningful study would be to compare a simple random sample from each of the two separate groups. And the problem is they've already made their selection. One group selected to take Latin, one group selected not to. So that really doesn't make a big difference. Okay. Also, you've also been giving definitions here. Please do go through those. Please go through your notes spiral and rework those problems. We will not have time to do this in class. You'll need to rework the problems in the note spirals on your own. All right, thank you.